now we go into next section, which is more based on application. We go into the frame and machine. Alright, frame and machine. So frame are commonly used to support various external loads. Alright, to support external loads. Load this one. You have external load here. Alright. So application, machine like this above are used in variety application. How can you determine the loads at the joint and supports? These force and moments are required when designing the machine members. So basically when you have load like this one, load, so this is a frame, frame machine. So how you want to determine the reaction at joint here, alright, how you want to determine that one, alright. Okay. Alright. So this is an example of a machine, the arm robots. Alright, we have various type of robots. Since you are in a mechatronics course, I think this is more suitable for you to understand. Alright, so you have very types of arm robots. So this is, you need to find what is the reaction at the joint. Okay, reaction at the joint here. What is the reaction when we want to design something? Alright, frame and machine are two common types of structure that have at least one multi-force member. Alright, multi-force member. Multi-force member means the member have a multi-force. Alright, you have 2000 Newton and then you have reaction at support, reaction at joint. Alright, and okay, steps let's usual. Draw FBD, identify two force member if any. For a joint with more than two member, to draw FBD, develop strategy. Alright, draw FBD of the frame or machine. Hints, identify any two force member. Alright, force on contacting surface, usually pin and member, are equal and opposite. Alright, ingat so two force member and force at contacting surface equal and opposite. For a joint with more than two members, it advisable to draw FBD of the pin. Alright, develop strategy to apply the equation of equilibrium. Alright, okay, a lot of practice need to use. Okay, this one, problem 11. Alright, so find the reaction at the pins at Z on the frame at A, B and C. Okay, you have A, B and C. Alright, find reaction at the pin. So you have pin here, pin, this one also pin, this one also pin. So find reaction at the pin. Right, so draw ABD for member AB and BC. Apply the equation of equilibrium. Alright, so if you want to draw equation of equilibrium, you need to draw FBD for each member. Let's say this one is AB, this one is AB, and this one is BC. Okay, BC. Kita pecahkan dia. Alright, pecahkan dia. So at A you have AY and you have AX. Okay, and then you have force here which is 1 kilonewton. At B, when we separate the member, they have also BY and BX. Okay, this one is joint. When we separate the joint, they should have opposite direction. Okay, FBX this way, this one also BX, this one also BY, but opposite. This one go up, this one must be go down, to the left, to the right. Ini yang dimasukkan dengan yang tadi, force on contacting surface, usually a pin and member, are equal and opposite. Equal and opposite at contacting surface. Alright, like this one, contacting surface, you have equal and opposite. Alright, Is it two force member? No, because they have one force here, one force here, and one force here. You have three, so it's cannot two force member. Alright. So draw FBD for AB and BC. Okay. So you have this one also. You have CY and you have CS. Okay. So find the reaction at support. Right. Find moment at A. Okay. Find moment at C is equal to 0. Right. And then you can find what is BY and BS. BY here and BS. Okay. So apply equation of equilibrium to bar AB. So this was AB. Okay, AB, BC. Alright. So you have AX, you have AY, you have BY, and you have BS. This one we already find just now, which is BY 0, BX 500. 0, 500. Okay, this one is 500. Okay, so you left with three unknowns, AX, AY, and BY for one member. And then you can choose equation of equilibrium to find the reaction. So Fx is equal to 0, Fy is equal to 0. So you can find what is AX and what is AY. Okay. So now consider member BC. Same thing. Summation of Fx is equal to 0. Summation of Fy is equal to 0. Alright. So Cy and CS. Okay. So you can get the answer CS is 500. Cy is 500. Alright. So you separate between two members, BA and BC, to analyze the problem. Okay. So this one is also same. This one is special. Okay. Why is special? Because this road BA, you don't have any other forces. You have only force at pin. So this one is two force member. Remember, two force member. So when two force member, you can only have force that in the line of action. So you have A, let's say this one FA, and you have FB. Okay, so you no need to find AX or AY because you know already the direction. So you have FA and FB. Right, basically FA and FB are same lah. FA same with FB. Alright, or we can say it FAB lah. Alright, FAB. Alright. So separate the member between BC and AB. This is BC, this is AB. Okay. So for member BC, you left with 1, 2, 3 unknowns. Okay, so you can solve using usual equation of equilibrium. Summation of moment at MC equals 0. Fx is equal to 0 and Fy is equals to 0. So you get the answer lah. What is FAB, what is CS, and what is CY. Alright. Okay, problem 13. Problem 13 is not two force member, alright, because they have external force here. Alright, 8, 8 and 10. Okay, so you need to separate the member AB and BC. Remember, okay, so when you separate the member at the joint here, you have same value but different direction. BX this way, BX this way. Alright, different direction, opposite direction. Same magnitude, opposite direction at contacting joint. Right. When we separate that one, okay, remember at A, this is feet support. So this is pin and roller. Okay, when feet support you have 2 or 3 AX, AY and moment. Alright. For the pin you can only have CY. Okay. So for the member AB you have 1, 2, 3. You have 1. You have 1, 2, 3, 4, 5 unknowns. For the member BC you have 1, 2 and 3 unknowns. So you can solve this using first, okay, using equation of equilibrium. F at 0, a moment at B0 and Fy0, you get the answer Bx, By and Cy. You get the Bx for here, okay, you get the Bx at here, it's same with here. You get By at here, it's same value at here. You get Bx for the member BC. The value of Bx are same for the member AB. Here, Bx. Okay. So you can, when you find Bx here, you can also apply value of Bx into here, segment AB. Alright. When you get the value of By, we need to find later lah. Alright. Okay. Right. So when we solve this, we get the answer lah. As what, Bx is what, Cy is what, and moment is what. Alright.